Do you know where we are right now, on Mars? It's an unusual image, isn't it? It's as if this whole thing was filmed somewhere on tension. Just look, a geologist with a backpack will appear over the horizon. For many years, it was believed that Martian landscapes were incredibly cosmic, but it turns out, look, it's much simpler. These images were recently transmitted to Earth by the American Perseverance spacecraft, equipped with incredibly precise optics. And these images have already become a real sensation. And now we know exactly what Mars looks like, what color the sky is on Mars, and what Mars smells like. It turns out there are wines on Mars. Want to hear it? Then let's listen. The sounds of Mars were also recorded for the first time only recently. It's just that the technical capabilities have become available. In general, we've recently received a colossal amount of information about Mars and space. Much of it turned out to be unexpected, and sometimes shocking. Martian wind. What is it like? It turns out it's prickly, icy, and deadly to humans. Why? Basically, no cosmic magic. How do we know this? An unmanned station operating on Mars has thoroughly studied the composition of its soil. And it turns out it's a mixture of sulfur, magnesium, iron, and chlorine compounds. Altogether, it creates that smell. This fact might shock the romantics of interplanetary travel. However, there's no time for disappointment. Scientists recently received fresh footage of a spacecraft landing on Mars, and it was truly sensational. Look, did you notice? Because the Martian atmosphere consists primarily of carbon dioxide, nitrogen, and argon, with a small amount of oxygen and water. Don't let these earthly ingredients fool anyone. Such a gas mixture is unbearable for humans. But if you could inhale this wind deeply, what would Mars smell like? Today, science can answer this question with certainty. Martian wines have a pungent, all-pervasive scent of spoiled chicken eggs, blood, and rust, with a slight Swedish tinge. The sky on Mars is blue, and this is a new, unexpected reality. After all, for many years it was thought to be at least orange. Ever since this spacecraft first sent back color images from the surface of Mars, NASA has been stunned. Mars turned out to be anything but red. So why did we previously think otherwise? What color is Mars really? The distortion of spacecraft photographs is due to the way the cameras on these spacecraft work and the lighting conditions in space or on the planet where the images are taken. Look, it's hard to believe, but Martian sunsets and sunrises are also blue. Why? Scientists believe that human eyes perceive Martian images in such a blue color scheme due to atmospheric refraction. That is, the way gas refracts sunlight. That's why Martian sunrises and sunsets are mostly blue. Now pay attention. Let's look at another of the most recent images of Mars from orbit. Look at the crater wall near Hellas Planitia. You see, it's multicolored, but the blue tint is clearly visible. Why? Where do the sands on Mars come from? After all, we're used to thinking that the entire surface of Mars is reddish-brown or dark orange. Who's right? This image or our usual perception? It turns out that both are slightly embellished. In fact, the image of the relief we see and its actual color are very different from each other. Why? Look, this panorama was taken by the Kossi spacecraft of the Russian European e-commerce mission. It is the most highly sensitive color telescope in orbit around Mars. And here are the images taken by this spacecraft. Very natural colors, right? Meanwhile, Roscosmos refers to this image of the crater as photochromic. What does that mean? Photochromic is a technology that emerged at the dawn of photography. Back then, all images were taken in black and white. They were applied to glass plates and then colored. That's why today, all images whose color rendition has been intentionally altered are called photochromic. However, the Cassis telescope is a giant, ultra-sensitive color camera that can capture images in a variety of spectra, even those invisible to the naked eye. So why are these images also recolored? It turns out there's a lot of practical value here. This is done for the convenience of geologists, so they can more easily see different rocks that reflect light differently. The lighter parts in the panorama are presumably clay minerals, while the darker parts are ferrous. I don't want to upset anyone, but most of the most mesmerizing images from space that we admire are also photochromic. That is, they're colored. The Hubble Space Telescope, It's thanks to it that over the past quarter century we've been able to see how incredibly beautiful our universe is. Let's admire it too. These are perhaps Hubble's most impressive images. The Pillars of Creation, the Lord of the Rings Nebula, the heart of the Whirlpool Spiral Galaxy, the Horsehead Nebula, a cluster of young stars in the constellation Carina, is the Esky Nebula, the Brain, the Tadpole Galaxy, and, of course, the famous photographs of Mars. Now for the harsh truth. In fact, it can only create black-and-white images, while scientists are already making them in color. If we could see these objects, everything would look completely different. Not so beautiful, but at least it's true. But how are space images obtained? When photographing objects at a great distance, black and white carries much more information. Plus, these images are taken under different filters. That is, they need to shoot in the ultraviolet and infrared. That is, different filters are applied, and we, well, as a human, won't see anything. Then it all gets deciphered. A completely different panorama emerges. But this is necessary, again, to obtain scientific information. The human eye, as we know, is capable of perceiving only a very narrow range of waves. But spacecraft can also receive information in the spectrum invisible to the naked eye. The main task of orbital telescopes is to measure the brightness of light from space objects. It is by the emitted waves that spacecraft locate stars and galaxies, and by the reflected ones that they locate planets. Color is added later in color correction programs. This is done according to a strictly scientific procedure and not for aesthetic purposes. To visually perceive the resulting image, astrophysicists assign colors to gases and other chemical elements. Each wave has its own color. The goal is to understand the nature of the object in the photograph. On the surface of planets, scientists are particularly interested in the composition of the soil and subsurface. In space, they are interested in the composition of stars and nebulae. Thus, space images are not fakes, but chemical maps of the rocks that make up a planet or star. And if we could see these objects in the full spectrum, they might seem even more beautiful.